Hello everyone. I hope everyone's doing okay today. And we're going to be doing, I'm going to continue from where I left off on last Wednesday. And that's beating up on the electric universe. Electric universe is a little bit of a ragtag army of people who claim that they don't agree with the establishment. That's not totally true. They seem to disagree with general relativity, but they don't seem to disagree with quantum mechanics. And they are essentially a branch of quantum mechanics, and I'm going to go over that. What's the problem with the electric universe? I'll just start where I started the other day. I'm just going to go through this relatively quickly. If you already watched the previous presentation, then you'll get an idea. You already have an idea of, where the starting point is. The starting point is here. The question is the electric universe scientific? The answer is no. And electric universe is just a sect of quantum mechanics. And why is it a sect of quantum mechanics? Why isn't it scientific? Because it is in the business of moving concepts. Okay, that's going to be the basic argument. Electric universe moves concepts around, and they believe they're moving objects. And that's essentially the same underlying problem that we have with all of mathematical physics. And the electric universe is no exception to that rule. So where do we start? We start at the golden rule, as I call it, the golden principle. Physics requires an object. You can't do physics without an object. And what is an object? An object is that which has shape. That's our starting point. Okay? Doesn't mean you have to agree with either statement. If you don't agree, then you have to provide your own version of what is physics. If physics ever requires an object, and define the word object. That's simple as it is. So if you believe that it does require an object, if it doesn't, well, then you're in trouble. Because I would think that, you can't do many experiments without objects if experiments are part of physics. A lot of people seem to think that experiments underlie science in general and physics in particular. And if that's the case, well then, what are you going to do in the lab? What are you going to play with if there are no objects whatsoever? And the other scenario I always paint is God comes in and he erases all matter from the universe, just leaves empty space, vacuum, nothing. What is happening in such a universe? What is occurring? And one of the counter arguments that some of the people have out there is that, well, we can deal with concepts. We don't need to have the objects per se. We can start, talking at a higher level, if you call it that way, and say, well, you can deal with concepts. What these people don't realize, that all concepts are founded upon objects. You must have some kind of body, some kind of substrate. You have to have something at the end of the yellow brick road. You can't just deal with concepts. And all concepts are founded upon objects. In fact, my definition of a concept is that it is a word that invokes or embodies two objects. So you can't define the word concept scientifically without an object. Just like you can't define the word motion without an object. Hopefully you need an object to move, and people, in quantum have eventually worked themselves into a corner where they say, well, particles are really a vibration of a field, or particles are vibrations of electromagnetic fields, or of I guess whatever's out there. It's a vibration of vibrations, because in the end they never defined the field other than as a bunch of vectors. So no, you must have an object at the end of the yellow brick road. You can't just go make all this itinerary, all this intellectual path, and not arrive at an object. You must have an object, whether you're dealing with concepts or whatever. So physics does require an object. You don't have any phenomena occurring without an object. And again, people don't have to agree with me. They just need to provide their own version. They say, if you're wrong, Bill, then what is right? That's what you got to provide. It's not sufficient to say, well, I don't agree with you, and I'll leave it at that. No. So what are the problems with the electric universe? Well, the first problem is that if we're going to apply the rule, the golden principles, I call it, the fact that you need an object, and we're going to apply also the definition that an object is that which has shape, we must use these words, these principles, to any physicist, any person who's out there. We have to treat them with the same standard. And so when you apply this to the electric universe, that's where the electric universe falls apart. First, they don't do physics with objects, and they never have defined objects. And in fact, like I say, they're a branch of quantum mechanics, as you'll see in a minute here, because they use the same terms as quantum mechanics. They use the same terms as mathematical physics in general, and they're in the business of moving concepts. They transfer energy, and they think they're transferring an object. They talk about fields, and they think they're talking about objects, and their whole system is based on particles, just like quantum mechanics. So there is no difference between the electric universe and quantum mechanics as far as the foundations are concerned. Where the electric universe differs or attempts to differ is that, they don't have, for example, in the case of a star like the sun, they don't have the reactions going on in the center of the sun that quantum proposes. They believe that it's all surface, or primarily surface phenomena that creates the heat of the sun, and the chromosphere and that kind of thing, the outer skin of the sun. That's one issue. And the other one is that they use the word plasma. They love this word plasma. And just very briefly, just to cover what we did last week, here's a summary. The problems with the electric universe is first that they use words such as plasma, electricity, current, vortex, and ether. Not again, and since they're a ragtag army of opponents, they don't all agree on these terms. Not all of them use ether, not all of them use vortex, and so on. But irrelevant. Whichever of these five terms an electric universe member uses, none of them qualify as objects. None of these are objects. And especially when you use plasma and electricity, people in the electric universe get very, very offended. They've told me in the past, what do you mean they're not objects? What do you mean plasma is not an object? Or they'll tell me something like, electricity is not an object. Go put your fingers in an outlet, and you'll tell me if electricity is not an object. And so again, they're not defining the word object. An object is not that which you can touch or see. An object is not that which you test by running an experiment. An object is that which has shape. Electricity doesn't have shape. In fact, quantum and the electric universe have this notion that electricity is just a flow of electron balls. You know, they use Niels Bohr's quantum atom, planetary atom. Okay, and that's the first part. Then you have this, the U uses the quantum planetary atom, just like quantum. The electric universe invokes mathematical physics jargon. I'm going to go over that a little bit. The EU talks about empirical evidence, experiments, predictions, observations, running experiments. What else? In general, they use the same notions that quantum mechanics and mathematical physics have. In fact, they do try to put some of what they propose in mathematical terms, like if that were important, you know. So they want to fall in with what is required by mathematical physics, and they say, let's do some equations so that we show that we understand and we know and that we have proof for our theories. And again, mathematics has nothing to do with physics. And you got to watch another of the videos to understand that. And then the last one, EU censors critics. I'm going to talk about these last two points at the end. Okay. Okay, so those are the things that are wrong with the electric universe, and just very quickly, just what I covered last week regarding plasma. I'm just going to run through it. What is that? This is according to their website, to the electric universe website. Plasma is a collection of charged particles. That's what plasma is to them. Okay, charged particles. Again, particles. That's quantum. The defining characteristic is the presence of free charges. That is, the ions and electrons and any charged dust particles. So we're talking about particles, we're talking about electrons if they were beads, as if they were beads, and we're talking about ions, which is what? They're referring to an atom that has lost an electron bead and now is positively charged. And then we have a second notion of what plasma is, and that one's at the bottom. It says plasma is usually considered to be a phase of matter distinct from solids, liquids, and gases. It is often called the fourth state of matter. Okay, and what's the problem with that? Well, the problem is here. The last one. Let's start with the last one first. Last one shows this. So you have solid. And depending on the higher temperature or you know, everything else remaining the same, like for example, if you hold the pressure and everything the same, you raise the temperature, well, a solid, if you raise the temperature high enough, it's going to turn into a liquid or sometimes directly into a gas. From liquid, it can go into a gas, and from gas, it goes into a plasma, where it's the temperature so high that the atom loses electrons and now becomes ionized. Okay, what are these? All these are four states of matter, and plasma is considered the fourth state. Some consider it the first state, depending on in which direction you look at this graph, this representation there. And so, what's the issue? The issue is that solid is not a physical object. Solid is a category. It's a category of matter. So, you know, if you find a piece of iron, you know, or a rock, you say, well, that's solid. The rock is the physical object. Solid is a category that incorporates things like rocks, trees, houses, chairs, etc. Liquid, same. It's a category. You have all kinds of liquid. You have oil, you have water, molasses, all those you can call liquid. Gas, you know, you can have air, most famous gas probably, but then you have all these gases in the periodic table, nitrogen, oxygen, and so on, helium, hydrogen. So these are different states of matter. And plasma is one of these states of matter, and it's a little different than the others in the sense that now we are breaking up the atom. And this is a soup in which you have all kinds of particles. Supposedly, we're going to assume we have all these particles, and they have lost an electron bead. So if plasma is a state of matter, like Kansas is a state of the union, then it's not a standalone physical object. It's a category of matter. And then plasma does not qualify as a standalone physical object under that notion of plasma. And the other notion of plasma, let's get it back there again, which is the first one, a collection of charged particles, and the second one, the defining characteristic is the presence of free charges, right? If we consider plasma under that notion, we're no longer treating it as a state of matter. Now we're saying, look, it's a gas that has lost, that some of its atoms have lost electron beads, and they are positively charged, and you can move these ions around with magnets and with electricity, and you can also create a flow of beads, electron beads, and we'll call that electricity. Then now we're not talking about a category of matter. We're not talking about the fourth state of matter. Now we've got a different category, and that's a soup that has all these particles, and they're all charged particles, whatever charge means, okay? So these are two notions that the electric universe uses, and they don't realize that it's a contradiction, because you can't have plasma. The word plasma mean two unrelated things. It cannot be on the one hand a category of matter, and on the other one be a specific gas that has a special mix in there. And the biggest problem there as well is that if plasma is a soup in which some of its constituents have lost an electron bead, that lost an electron bead, that's a verb. You have to do something to that gas. You have to ionize it. And the word ionize is a verb. I ionized an atom, and they don't realize that. They think that plasma is something that is static. And here I have a picture of what plasma is, and there you have it, folks. That's plasma. And you can see that it's always in motion. If I take a snapshot of that, what I will see is particles. And particles are not the defining characteristic of plasma. It's what you can do with the plasma and how you got there. How did you get the plasma? Well, you had to raise the temperature. You had to remove electrons from their atoms, turn them into ions, turn what's left behind into an ion, and you have this soup of electron beads flying around inside a chamber, for example, and you have atoms in there, and you have also ions. And one of the questions pops up, is why don't the electron beads, why don't they recombine with the atoms? You have these the blue ones. Think of those. I guess those are the electrons there. Why don't they recombine with the atom? The atom is starving for a negative charge. The electron is starving for a positive charge. They're all in the same soup. Why don't they recombine? And they say, well, yeah, because you have higher temperature or whatever's breaking the atom apart. Okay, fine. But again, you got to keep that in mind that, you've got this soup in there. And what they do usually to make plasma useful is they manipulate this with magnets, one way of doing it. And so you can move the ions out of there. You create this plasma. Once it's ionized, the ion, we'll call it positively charged, whatever that means. And now you can manipulate it with magnets. You can crush it into a little beam, like a pencil-like beam, or you can make it, into something wide, depending on how you play with the magnets. In other words, you can manipulate plasma once you have, these charged particles in that soup. But the bottom line is that plasma is something you do to a gas. Do is a verb. And the electric universe never realized that and does not understand that. And will never understand that because if you destroy plasma, you destroy the electric universe. So they can't say that plasma did this or plasma did that. it's gas can do this or that, because a gas, if I take oxygen, for example, and say I have a balloon filled with gas. What is that gas? It's oxygen. Well, I can do something with it. I can bang the balloon against the wall, or release the balloon, pop the balloon in space, release the air in space. And maybe that air does something, okay? And so I can say that air did this and air did that. I can do that. I cannot say plasma, because first I got to do something to that same gas. I got to ionize it. And so, plasma is a movie. You have to do something to the gas in order to be able to make it useful, in the sense of being able to manipulate it with magnets or electricity. And that's the issue. The issue is that plasma is not a noun, plasma is a verb. And they'll never understand that, no matter how you twist and turn it. Okay, and just to make sure, here we have ionization according to quantum mechanics. An atom, in this case, I guess it's the hydrogen atom, but it could be any atom for that matter, loses an electron. The electron is negative, leaves behind a positive ion. That's essentially what ionization is. That's the process that is happening when you turn a gas into plasma. Not to every atom, but to most or some of them at least. Okay. And what does the electric universe do? Well, they have the same notion. This is a picture from their site. And here you can see that the electron, let me move this guy aside a little bit here, just so we can see them side by side. What they do in the electric universe is show this picture. And this picture shows the same thing that you see on the right over there, which is the atom, whichever atom that you have, loses an electron bead, and that's how it becomes the atom becomes ionized. It becomes an ion. It can be manipulated because now it's a positive charge. That's essentially the same thing that quantum proposes. Okay, so that's our notion of ionization for the electric universe. That's what underlies plasma, and so therefore plasma cannot be a standalone object. It's something. It's a phenomenon that has occurred. You did something to a gas in order to turn it into plasma. And again, if you lower the temperature, there's going to be a recombination of electrons with the ions. And again, you get back your atom, and now you can't manipulate it any longer. Okay, so to summarize, let's see if I can put that a little bigger. Plasma is a category of matter and a dynamic concept at the same time. And so that's one of the fatal problems that the electric universe has to fix. The other one, there's no such thing as plasma any more than there's a thing as wind. Air is the object, wind is what air does, and that's more or less a good analogy for plasma. Gas is the object, plasma is what it does. You have to ionize the gas, okay, before you can do something useful with it. It invokes plasma, in other words, the ionization that the electric universe proposes. It invokes Bohr's planetary model of the atom, which even the mechanics have already debunked. So I suppose the electric universe is behind on the times. They haven't figured out that their atom has been debunked. And the electron, in that case, is a discrete bead. It's the thing that's orbiting or jumping around the nucleus. And it is when you remove that discrete bead that you create electricity. Okay, and I'm going to get into that in a second. Those are, in a nutshell, that's in a nutshell what is wrong with the electric universe regarding plasma. Let's move on now to the electricity, the other important part of the EU. But before I get into the electricity, let me just show the language. I want you to look at the language that the electric universe uses. See if it sounds familiar to you. Have you heard it before somewhere? Here's the first one. These are statements taken out of their website, by the way. So a solid such as a metal electrical cable, once it will have its electrons separated from the metal nuclei. That means electrons are treated as beads there, to be moved freely along the wire as a current of charged particles. So the electrons are going to move along a wire. That's going to be called a current. And what is the current made of? It's made of charged particles. Now, did you ever hear that somewhere else? Have you ever heard of that before? Yeah, this is language completely belongs entirely to quantum mechanics, mathematical physics. So there's no change there. The electric universe has not discovered anything regarding what electricity is. Second one there, a molecular cloud of very cold gas and dust can be ionized by nearby radiating stars or cosmic rays. Okay, so that's how you get them ionized, okay? With the resulting ions and electrons taking on organized plasma characteristics. Okay, so it's going to be ions and electrons. That's going to be the plasma. What are these ions and electrons? They are discrete beads. That they're treating the electron as a discrete bead and the ion as a a bunch of balls there that are in the center, in the nucleus of the atom. Such plasma will accelerate charges. Accelerate charges. Charges is a concept. You do not accelerate concepts in physics. Charge is not a physical object. In fact, I can tell you the value of charge is 1.6 times 10 to the minus 19 coulombs. And to treat this number as a physical object and tell the crowd that you're going to accelerate this number, well, that's essentially what these people are saying. We know that space is filled with fields. Fields? Space is filled with them? What's a field? I mean, what are we talking about? Marijuana field or cornfield? What kind of fields are these? A variety of particles. So they think of a field as a variety of particles. And here, let me give you a little example before we continue. Here you have a variety of particles. It's a field. It's also a plasma. So plasma equals field. Field equals plasma. You have atoms, which is the red one with the blue one next to it. You have ions, which are the red ones with a positive sign above their heads. And you have the electrons, the free electrons, which are the little blue ones with a negative sign. And this soup is a plasma, and these are what they just defined as a field, which is, let me put that back, which is an organized no, where was it? We know that space is filled with fields, a variety of particles. Oh, here you have a variety of particles. You have variety of particles. You have some which are atoms, some which are ions, and some which are electrons. So that's a field. Do you think that maybe the the people in quantum mechanics would agree that a field is a bunch of particles? Is that what a field is? Well, I don't want to get ahead of myself because I'm going to be talking about fields next week, and I got a lot to say about fields because just in general terms I'll tell you what I'm going to be discussing, and that's that what these people have done in quantum is in the 20th century they were talking about particles, and now they left the particle behind and said, well, it's really not particles, they're fields. 20th century, particles. 21st century, fields. Okay, so I'll be talking about that. But for sure, let me tell you that in advance. According to quantum mechanics, the new religion that quantum mechanics has is that a field is not a bunch of particles. Okay, and so this notion that the electric universe is here, I'm sorry, wrong one, that the electric universe has here, that fields are a variety of particles, the electric universe may want to update that because it's not true anymore. And says many of which are charged. Okay, so we have charged particles. That sounds quite a bit like quantum. If an electron, one negative charge, quantum, is separated from an atom. Again, if you separate it, you're talking about a little bead. Then the remaining part of the atom is left with a positive charge. Have you ever heard of that before? Energy is required to separate atoms into electrons and ions. So again, we're talking about energy doing something, a physical object that does something to electrons and ions or to atoms. So energy, is that a word invented by the electric universe? No, that's a word that they borrowed from quantum mechanics. And they may claim they borrowed it from classical mechanics. But energy is a word that's already been hijacked by quantum. Due to the presence of charged particles, hopefully you heard of that before, that is ions, electrons, and charged dust particles, cosmic plasma behaves in a fundamentally different way from a neutral gas, in the presence of electromagnetic fields. Presence of fields. Fields is a concept. There's no physical standalone object called field. But there, as you can see, they're talking about presence of fields. They believe that fields exist. They think it's a physical object, and plasma is affected by these fields. So we have a concept affecting another concept. And then they talk about electromagnetic forces, another physical object called forces. I hope they can draw one, will cause charged particles to move. So we have forces compelling charges to move. One concept pushing on another. All their language is bogus. All their language is from quantum mechanics. And so, the electric universe has nothing to offer in that sense. They essentially are a branch of quantum mechanics. They might claim that they're a branch of classical physics. They would like to think of themselves as classicers. In other words, they say, we're using plasma, and plasma is ionized gas, so we're talking about objects, so we're classical. Whereas quantum mechanics works with voodoo, black magic. They talk about these particles made of more particles. And the electric universe stops at the last particle, the atom. They don't go further. They don't care about quarks. They don't care about gluons. They don't care about all this stuff. They say, look, we can explain the universe with atom and upwards. And that's classical. And when you get deeper in there, then now you're dealing with quantum mechanics, not classical mechanics anymore. And they don't like to deal with that because they say, look, we think you're going too far. You're just creating more and more particles, giving names to particles, and it makes no sense. And we cannot explain how the universe works with gluons and all this other stuff that you invented out there, pions and muons and so on. They say, this is simple. We can do it with plasma. And plasma is simply ionized gas, period. And so in that sense, they are a branch that is trying to make more sense of the universe by trying to use classical mechanics. The problem is that the atom belongs to quantum mechanics, not to classical mechanics. The atom is the Bohr atom, the planetary atom. That's quantum. And so if the entire electric universe brings words from the 19th century, but then uses the 20th century atom discovered and defined and illustrated by quantum mechanics, then we have a contradiction. They can't do that. They want to use classical mechanics and apply it to the planetary atom. That's the problem. And of course, they're going to use words such as energy, because that's what they learned in high school and college. They want to use words such as fields, energy, fields, mass. They don't dwell too much on math, but they do dwell quite a bit on charge and the electromagnetic fields. They like those words, those terms. They like those. And so again, they're applying language from the 19th century or up to the 19th century, what is known as classical mechanics. They're applying it to an atom that was defined by quantum mechanics. That's a contradiction. Okay, so they use essentially the same language and they have the same atom. What's the problem with that? Well, the problem comes when, first with plasma, but the second problem comes that they apply this to electricity. And all we have to do is look up, under the, what is it, the electric universe site, or the, what's the other one? The, forget the name of it, the Thunderbolts. The Thunderbolts, either one, the Thunderbolts or the Electric Universe are the same thing. They're two different websites, but they pursue the same religion. And when you look it up, you say, well, what is electricity? And this is how the EU defines it. But before they define it in their website, and again, you got to go to the website, don't take my word for it, okay? Before they define it, they begin with all these disclaimers. And the disclaimer is, well, no one can define words really. They dismiss all that stuff as semantics. They don't like to deal with words because they say, well, we didn't come here to do English. We're not English majors. We want to do physics. And so, and so they try to skip over defining their key terms. And here you'll see why. Let me show you the argument they make on their website. This is the argument. They say, defining what is meant by electricity often depends on who is providing the definition. Physicists and mathematicians define it in one way, while the man on the street defines it in another. Electricity is a fundamental quality of matter, so it is used to characterize other things. Thus, consensus opinion is lacking precision. That's how they started. In other words, they're already giving you the fine print, saying, look, nobody can define words. And so don't expect a solid definition of electricity. That's their disclaimer before they even define it. But I want you to notice something there. It says, electricity is a fundamental quality of matter. If electricity is a quality, according to the electric universe, quality is not a physical object. It's not a standalone physical object. Quality is a property. It's a characteristic of something. And to say that electricity is a quality, they're already defeating their notion that electricity is a physical object. Quality does not qualify as a physical object, if that's what electricity is. And this is using their own words. And no, we're not doing semantics. What I'm doing here is saying, look, this is your definition. I need to know if electricity is a physical object or an abstract concept. Here they defined it as an abstract concept. They can't say they're going to move electricity if it's a quality of matter. Second line there, like all bedrock presumptions such as gravity or time, reducing electric terminology into smaller units is impossible because it lies at the bottom of the lexical well. What they're saying is, words are made of more words. And if you're just going to ask, well, what does this word mean? And then you look it up and those are made of other words. Well, it's just a lexical well. You fall into this black hole of the lexicon, And so we can't define terms. So we're not going to define what electricity is because nobody can define any word scientifically. That's what they're saying here. All we can do is draw water from the well. But we can't make more water. So electricity, I don't understand that that analogy at all. It makes no sense to what the guy just said. So electricity must be defined in comparison to other observations that appear to have a relationship with one another. It may be dissatisfying to realize that we can go no further than that in our search. In other words, the fella here is saying once and for all, that and up front, and he's giving you this disclaimer. He's saying we're not going to be able to define the word electricity. And he's giving you all these excuses of why you can't define it because it's just a bunch of words, and words are just made out of more words, and so ad infinitum, and so we don't need all this stuff. We're just going to go ahead and use electricity as whatever we want it. Whenever we want it to be an object, it's going to be an object. Whenever we want it to be a concept, it's going to be a concept. And who came up with this? Well, it's the guy who censored me. His name is Stephen Smith. And I've got a video on that, so you can look it up. But he says, he continues, says, scientists, and now he's trying to give a definition now of what electricity is for the purposes of the electric universe. Keep that in mind. Scientists use the word electricity when they mean the flow of electric charge. Okay, so flow of electric charge. That means they're going to be moving something called charge. Electric charge, whatever electric charge is. Charge is a concept. So how can there be a flow of a concept? What is this? A flow of love? A flow of information? What concept are we flowing here? Spirits? Electricity, which we define as the flow of electric charge, travels through a circuit. Now it gets even worse. So we have the flow, which is traveling. We have a flow of something, and that flow is traveling. It shows you that that this fella, and he's apparently one of their gurus, has no idea how to define words in a scientific matter. And he gives little importance to definitions. First, by putting a disclaimer, and second, by saying that a flow travels. There is voltage to push it along through the wiring. So we have a concept called voltage, an abstract mathematical concept known as voltage, and you can verify this because you can have 5 volts, which is a quantity. So voltage is a quantity. It has nothing to do with physics. It's just a number that the electricians have used for a long time because they are able to measure some change from one end to the other, usually depicted as a gradient. And they say, look, we go from positive to negative. And we don't know what it is, but it's 5 volts. And that's voltage. And now they're saying this voltage pushes because they have no other way of explaining this or what they're talking about because they have no idea what voltage is. Voltage is simply a number. It's an imbalance between one side of the wire and another. That's all they understand about voltage. And they always, again, put a gradient, and usually they explain it with water, like saying, you know, if you have an inclined plane and you let water go, well, will go down the inclined plane. And you say, well, yeah, because there's gravity, you know, pulling on water. And they say, well, you know, the water that's flowing downwards, that's the current. But the inclined plane, that pictorially represents voltage. There's a difference in potential between the up part of the inclined plane and the down side, the lower part. Okay, so again, they don't have any idea what voltage is, but they talk about electricity. Electricity moves through a DC circuit. They define electricity as the flow of charge, of electric charge. Now they say that the flow of electric charge moves through a DC circuit. You see how their whole language is twisted because they don't even understand what they're saying. How can electricity move if electricity is the motion of charge? And charge is allegedly electron beads. So you can't say that electricity moves. You can say electrons move through a DC circuit. You can say that if an electron is a bead. And that's the only way you can understand it. But to say that electricity moves, it shows you they're very careless, completely careless with their language. This is not scientific language under any circumstance, but these people claim to be doing physics, which is a branch of science. As particles of charge. So electricity moves as particles of charge. And so what is a particle of charge? They're treating charge as a physical object. Charge is a concept, and measured in coulombs. And in AC circuits, the electric charge does not flow. Oh, thank God. Instead, charged particles in the wires oscillate back and forth. So the charge goes back and forth, and that's AC circuit. Whereas in a DC circuit, it goes in one way, I guess. Flows like a river, you know, from up to bottom, I guess, or from mountain to the sea. Is that what electricity is? Okay, so here we have it. This is my representation of the electric universe's electricity, a flow of electric charges, actually meaning flow of beads, electron beads. And I've put the atoms there, the big blue balls, that's the nucleus. You can think of those as protons and neutrons bunched up together in there. And what you have is in the valence shell, the outer shell of these atoms, you have a flow of electron beads. That's what it is. That's the way they visualize, or that's the way they define electricity. Okay, so again, as you can see, they're using Bohr's planetary atom, and that's a quantum invention. And so they try to apply classical mechanics to this quantum mechanical idea. That's essentially what's happening there. Okay. Okay. So that's electricity for you. What's the problem with this? Well, one of those is how they use electricity out there. And one of their famous terms is the Birkeland current. Birkeland current. What is a Birkeland current? Because they're very strong on Birkeland currents. They say, this is proof that our theories, cosmic theories, are correct. The Birkeland current, they have been proven, okay, through experiment and measurement and whatever. Okay, and so here's the Birkeland current. And the Birkeland current is a set of currents that flow. So we have the current, which is a current, great, and the current is what flows. I thought the current was a flow, and now we have the current that is flowing. Okay? So you can't say the current flows because current is already a flow. So all they're saying is that a flow is flowing. A flow of electron beads is flowing. We have a flow inside a flow. Along geomagnetic field lines. Field lines? What are field lines? I thought field was a concept, mathematical concept. Connecting the Earth's magnetosphere to the Earth's high latitude ionosphere. Okay, so we have one magnetosphere, one concept, and it's connected to the ionosphere, another concept. Great. In the Earth's magnetosphere, the currents are driven. Again, currents, a flow is driven. They treat current as a physical object by the solar wind. Okay, so we have the wind pushing currents. That's great. An interplanetary magnetic field. Again, the word field. And by bulk motions of plasma. Motions of plasma. Plasma is already in motion, so how can you move what is already in motion? What sense does that make? And again, through the magnetosphere. So this is what a Birkeland current is, if you understood it perfectly. Maybe you can explain it to me next time. Okay, so that's what a Birkeland current is, and again, that's where they're going to use the word electricity. Okay, because they think of currents as the flow of beads, essentially, and so they don't understand what Birkeland current is. They just say, look, we measured something out there, and that's interfaces or interacts with the solar wind, whatever the solar wind is, a bunch of particles that are coming out of the sun, including photons, I suppose. The electric universe probably uses also the famous quantum photon. And whenever they want, they can also turn it into a wave, the Maxwell's electromagnetic wave. I guess at the end of their magic wands, they turn a particle into a wave into a particle whenever it's convenient to them. Sometimes they treat these things as particles, sometimes as waves, and they say, well, it's duality, so we can live with that. And here's another, this is the one I like the most, the filaments. These are filaments that interconnect stars and galaxies. Okay, so now you're looking at the universe there, okay? And if you see correctly there, you see that all these stars are interconnected by what they call filaments. And what are these filaments made of? Yes, you guessed, plasma. What is plasma? Well, it's some kind of thingy out there that is ionized, and that means that current can flow under certain circumstances. But they're saying all these stars are connected by filaments. But see, if the filament is made out of plasma, and the plasma has current running through it, or the plasma becomes the flow of current, and how can that connect to stars, let alone to galaxies? How can that connect to stars? And what I'm referring to here is that, imagine two stars. And let's assume that there's plasma between these two stars. That's impossible, but let's just concede that. There's plasma between two stars. And what happens? You have current flowing. in there. You have electron beads going from one star to another. How does the one-way flow of discrete beads create filament attachments? Are they saying that this star is connected to this other star? That it doesn't fly away because the other star is pulling on it somehow? I mean, if that's what they have in mind, they better to think again, because what they're saying is you're throwing stones at the donkey and you're attracting it. You're throwing electron beads. One star is throwing electron beads at another star and somehow is pulling on it. So that's got to be clarified, whether they're using the electron bead, the filament, as a cable that interconnects two stars. That's different than saying, you know, I'm going to throw stones at another star. So you have to be careful how they answer that question. Are they saying that this filament interconnects and keeps them, because one of the characterizations that Thornhill, one of the gurus of the electric universe, has is that stars are lit up and they form like, you know, the lights on a Christmas tree. Like, you know, you got all these wires connecting all these light bulbs. And he gives this characterization of what's happening out there with filaments. You have all these stars, and they just form this Christmas tree out there in the cosmic world. And it's like, you know, these filaments interconnect them. And so whether they're connected in such a way that, you know, one is pulling on another, maybe that's their notion of gravity, that's got to be clarified. I'm not sure that is. I don't want to put words in their mouth. But if that's the notion they have to explain how throwing beads, one star throwing beads at another star, pulls on it. Okay, so that's one of the issues you got to keep in mind. Anyways, the filaments are made of plasma, and you have electricity. That's why it's called the electric universe, going from one star to another. What does that do? Does that keep them tied up? What's the point of having that electricity? Is it just throwing, you know, like Zeus throwing his thunderbolts? Is that what it is? Thunderbolts of the gods, you know, just what's the point of that? So it's throwing electricity. And anyways, what is the main problem, the underlying problem? Well, the underlying problem is that it's bogus. The whole thing, the whole notion is bogus. Let me tell you why. You know, I work with plasma quite a bit. And what you do in a plasma chamber is you first evacuate the chamber of all material, any air, anything that's in there floating around. You suck it up with first a mechanical pump, which is in line with in series, right, with a diffusion pump or a cryo pump. The mechanical pump takes the chamber down to usually the -3 level, -3 torr. And the cryo pump or the diffusion pump goes further, and they can take it up to the -7, -8 torr. So that vacuum chamber is practically, you know, clean. There's nothing in there. There's very few particles in a chamber that's pumped down to the -7. What do we do next? Well, in my business, we introduced argon in there. You introduce argon and you're going to ionize the argon because you're going to use it as bullets to shoot against a target called, could be an aluminum target, titanium target. You're going to use it as a machine gun. You're going to chip pieces of aluminum, almost pure aluminum, and they fall on a wafer and you give it, you know, these this interconnectivity eventually, the aluminum bus lines that connect all these circuits. So what happened? You pump down to -7 torr. As soon as you introduce gas in there, it goes back up to the -3 level. You know, sputtering, which is that process I just explained very loosely, is a process that is done in a -3 level. Only then can you have a current in there. You cannot have a current in the -7 range. Now, when we went to the moon, yeah, we did go to the moon. Sorry about that. They measured the pressure on the moon in the -11th range. much more vacuum or less pressure than I had in my vacuum chambers. And I think it was Apollo 14 or Apollo 15. They had a device that while the probe was flying out there in space, they measured the level of vacuum between the Earth and the Moon. So they said, let's check what the pressure is here. They measured it in the minus 12 range. So we have a minus 12 reading from one of the Apollos. I think it was 14 or 15. And we have a reading on the Moon. Also, I think it was the 14 or 15. One of those two also did the experiment on the Moon. They put a gauge there to read the pressure on the Moon. They wanted to find out how much vacuum there was, and essentially it's the vacuum of outer space or within the solar system. And they measured a minus 11. We have a minus 12 reading and a minus 11 reading, which is much higher vacuum than what I achieved in my chambers. You cannot achieve electricity, a flow of electron beads, when there are no beads. And in a vacuum chamber that's pumped down to the minus 7 range, there are no beads to flow. You cannot have a current in the minus 7 range, let alone in the minus 11th range. What are they going to use as bullets? And so what these people are saying is that they have a current out there in space in the solar system when the solar system has a minus 11 torr range of vacuum. That's very, very high vacuum. There's nothing there. In fact, if there was a plasma, and that plasma is causing electrical bolts, as they're saying, some of the surface features on Mars were carved by Zeus's bolts. Well, then poor astronauts, when they go out there, they're going to be, you have all this solar wind, and we're talking about minus 3 range. You've got all these particles out there of plasma, and they're all machine gunning our astronauts. They're going to turn them into Swiss cheese. So these people don't have the slightest idea of what they're talking about. There cannot be a plasma in the solar system in general, like between the planets or between the sun and the planets. There cannot be plasma between one star and another, and there cannot be plasma between two galaxies, because the range that we're talking about is the minus 11 torr range. When you go into interstellar space, they calculate it. They have not measured. They calculated it's got to be in the minus 16 range, and intergalactic space has been calculated, not measured, calculated to be in the minus 19th range. These are calculations. You can say you're going to believe them, you're going to assume them, whatever. The point here is that at least within the solar system, we have minus 11 torr range of vacuum. And if you have minus 11, you cannot have electricity. You cannot have what the electric universe is proposing, and that is that, you have all this electricity going from the sun all the way to Pluto. No way. Absolutely no way. You cannot have that. And this is where the electric universe essentially fails in the electricity part, aside from the plasma. So we have plasma that fails, first because of language, second because you cannot have a plasma in a minus 11 torr range, and if you don't have plasma, you don't have electricity. And so these are the things that the electric universe is completely nonsense, absolute nonsense. These people have no idea whatsoever what they're talking about. Okay, there's a couple more, but I guess I'll have to cover them on Wednesday because I ran out of time again. For now, I'll just say, summary, you can't have, what is ionization under the RH, asked Tom. Tom, I've got ionization in one of the two videos on, which one was it? It's one of these three. It's rope hypothesis number 2, or the neutron 1 or 2. It's one of those three videos. I can't remember which one. I do explain ionization in there, and essentially is Well, look at the video and you'll see what ionization is, because I'll waste too much time trying to explain that detail. But I have it visualized. Okay, I have a little. Okay. Anyways, just to summarize here, plasma fails on the fact that it can be treated as a fourth state of matter, in which case it's a category of matter. And then on the other hand, you can say that it's ionized gas, in which it's a verb, something happened to the gas. And second, or third, it's using Bohr's planetary model. So it's a quantum atom that they're using. And they're trying to apply classical mechanics to that, using words such as energy and fields and waves and so on. And in the case of electricity, more or less the same thing. You can only have electricity if you do have a plasma, assuming the universe is full of plasma. It's got to be in the -3 torr range. And if this plasma is out there, we should be able to measure it. I mean, if they talk about measuring and running experiments and observations and whatever, fine. We have measured. We have measured the vacuum of space, the level of vacuum of space in the -11, -12, 12 torr range. That's insufficient to create a plasma or to create electricity. And so there is no electricity between planets and stars, between galaxies. There's no such thing. And so those two pillars of the electric universe fall completely apart. And that's where the electric universe fails. Language and also proof, if that's what we're going to talk about. The measurements do not support what the electric universe is proposing. With that, I'll see you on Wednesday, and I'm going to be talking about a couple more issues. I'll do another quick summary and then talk about a couple more issues related to the electric universe. And then hopefully I can get into subject matter that is of more interest to me, which is how quantum has gone with this word field. They've gone from the particle to a field, and that's going to be very exciting. So we'll see you on Wednesday. We'll see you then. Bye-bye.